Good day, everyone. Greeting of health and prosperity to all. See you again in the data analysis and visualization course. The topic that will be discussed in this meeting is intermediate visualization and calculation using Tableau. Still with me, Leon Andretti Abdillah. Assalamualaikum warahmatullahi wabarakatuh. Good day. Greetings of health and prosperity to all of us. Welcome, fellow students who I love and I'm proud of, whenever you are. May you always be in good health and under the protection of Allah Subhanahu wa Ta'ala. Amin ya Rabbal 'Alamin. Lecture untuk mata kuliah ini adalah Leon Andretti Abdillah, saat ini sebagai Associate Professor Computer Science and Information System pada Faculty Science and Technology. Kemudian juga bertugas sebagai asesor, reviewer, research fellow, dan editor, asesor BKD di Kemdikbud, kemudian reviewer di Kemdikbud, research fellow INTI International University Malaysia, serta research fellow Tsinghua University Taiwan, dan menjadi editor pada sejumlah international journal dan conference. Mata kuliah yang diasuh antara lain adalah HCI, KMS, CRM, kemudian ada BPP, BPHEM, Databases, Data Structure, ERP, Information System, ITSM, Management Information System, Supply Chain Management, System Analysis and Design, Algorithm and Programming, dan lain-lain. Juga sebagai mentors, ini ada di Pablo New Zealand dan Unpad Indonesia. Kemudian ada sebagai consultant baik di bidang akademik, research, dan community, serta koordinator pada Research Center dan Enterprise System Research Group. Berikut sejumlah mata kuliah yang diampu, dimulai dari System Analysis and Design, Enterprise System, Research Method, Human-Computer Interaction, Knowledge Management System, Human Capital Management, Algorithm Programming and Data Structures, Supply Chains Management, Business Process, serta beberapa mata kuliah lainnya.
This course provides hands-on training in data analysis and visualization using Excel and Tableau. Students will learn to analyze, visualize, and present data insights effectively for great decision-making. In Excel, students will explore key tools such as pivot tables, advanced formulas, and charting techniques to clean, analyze, and visualize data. They'll develop the skills to create impactful reports. In Tableau, students will learn to build interactive, visually compelling dashboards and charts. They'll gain expertise in connecting to data sources and creating insightful storytelling visualizations.
Oke, sekarang baru masuk ke course objektif ya. Students should be able to the following by the end of the course. Jadi ada sejumlah hal yang diharapkan dapat dikerjakan oleh mahasiswa setelah mengikuti perkuliahan ini. Yang pertama itu adalah Master Data Analysis Technique. Jadi, with Excel and Tableau, student will learn fundamental data analysis concepts like data cleaning, transformation, and statistical analysis. Jadi teknik analisa data yang utama itu meliputi data cleaning, transformasi, juga sampai ke analisa statistika ya. Yang kedua adalah Excel Data Management. Learn how to manipulate and analyze data effectively using Excel features such as formula, pivot table, Power Query, and Power Pivot. Nah, ini adalah mengelola data secara excellent ya, meliputi ada formula, ada pivot table, Power Query, dan juga Power Pivot. Yang ketiga yaitu Effective Data Visualization. Learn best practices for producing meaningful representation in Excel and Tableau that effectively communicates findings. Nah, ini cara memvisualisasikan data yang ada ya, sehingga dapat menjadi sarana komunikasi yang baik. Yang keempat adalah build interactive dashboard ya. Learn how to create dynamic and interactive dashboards and reports in Excel and Tableau with a focus on interactivity and data storytelling. Nah, ini juga yang cukup penting adalah dashboard ya. Di sini data tadi dapat kita ceritakan ya. Nah, kalau ada dashboardnya dapat kita ceritakan seperti storytelling, kira-kira seperti itu. Last but not least, yang kelima adalah apply data analysis to decision making. Learn how to use data insights to enhance decision-making process, as well as industry-specific data visualization use case. Nah, di sini baru cara pengambilan keputusan ya. Jadi visualisasi tadi itu bisa dibuat untuk proses pengambilan keputusan. Oke, sekarang masuk ke course expectation. Yang pertama adalah attendance dan enrollment. Jadi mahasiswa diharapkan secara reguler itu hadir ya, bisa secara offline ataupun online, termasuk juga dalam diskusi, dalam forum, serta kegiatan berkelompok. Yang kedua adalah task and assignment. Jadi selama perkuliahan Anda akan mendapati sejumlah tugas-tugas, bisa juga kuis, ujian untuk menilai seberapa capaian pemahaman Anda terhadap konten mata kuliah ini. Kemudian ada juga group project. Mahasiswa diminta untuk bekerja secara kolaboratif ya, berkelompok untuk mengaplikasikan knowledge management principle ke dunia nyata yang mungkin ditemui. Yang keempat adalah reading and resources. Nanti kita akan berikan sejumlah recommended reading and resources. Jadi diharapkan Anda mempelajari materi-materi tersebut sehingga dapat meningkatkan pemahaman dari subjek ini. Selanjutnya perlu diperhatikan juga regular office hours ya. Jadi kalau mau bertanya, konsultasi itu fokus pada jam kerja ya. Jadi saya meminimalkan kontak di luar jam kerja. Kemudian harus bersikap profesional, respectful ya, baik terhadap karyawan ya, dosen, rekan-rekan dan lain sebagainya. Kemudian communication juga penting ya. Jadi kalau mau bertanya itu harus jelas dan usahakan pada waktunya. Kemudian yang kedelapan adalah ethical conduct. It is critical to maintain academic and ethical integrity. Termasuk juga nanti ada kita harus menghindari yang namanya plagiarism dan juga cheating ya, baik pada saat belajar, tugas ataupun ujian. Kemudian tak lupa adalah feedback. You will receive constructive feedback on your assignment and project to help you improve your understanding and performance.
In Tableau, various chart types are available to help visualize data effectively, each suited for different kinds of analysis. Common chart types include bar charts for comparing categories, line charts for showing trends over time, pie charts for displaying proportions, and maps for geographic data. Understanding when and how to use each chart type is key to presenting data clearly and drawing meaningful insights. This section guides students in selecting the right chart for their data. It covers key factors like data type, audience, and analysis goals. Students learn how to use visuals for clear storytelling. Common mistakes such as misleading axes or cluttered charts are discussed. The goal is to build visuals that are accurate and impactful. This section teaches how to build visuals using Tableau's drag-and-drop interface. Students follow step-by-step instructions to create basic charts. It emphasizes ease of use and quick insight generation. Best practices like clear labels and consistent formatting are introduced. The focus is on creating clean, readable visualizations. This section shows how to customize charts for better clarity and engagement. Students learn to change colors, fonts, and layouts to enhance appearance. It also covers adding interactivity through filters and highlights. Tooltips and marks are used to display extra data details. These features help make charts more dynamic and user-friendly. This section guides students through creating a simple dashboard in Tableau. It provides clear instructions and lists the tools needed, like charts and filters. Students learn how to arrange visuals for impact and clarity. Tips include keeping layouts clean and focusing on key insights. The task builds confidence in combining charts effectively. This meeting introduces students to the fundamentals of building basic visualizations in Tableau. Students will learn how to create bar charts, line graphs, and pie charts using sample datasets. The session emphasizes understanding chart types and when to use them. By the end, students will be able to construct clear, effective visuals.
Agenda. Our meeting is divided into 5 subsections. Start from calculated field, cover basic formulas, profit margin calculation, and growth rate calculation. After that function, we'll discuss date function, string function, using function for analysis. After the charting techniques, we'll discuss dual axis charts, combined charts, visualizing sales and profit, and visualizing sales and profit. After that, parameters, introducing to parameters, parameter use cases, benefits of parameter analysis. And lastly is level of detail or LOD, explaining fix, include and exclude, comparing LOD with table calculation, and use cases for cohort analysis.
This presentation aims to elevate your data visualization skills by exploring calculated fields and more complex chart types. We'll delve into creating custom metrics, manipulating data, and combining different visualizations for enhanced storytelling. Get ready to unlock powerful techniques for deeper data analysis and more effective communication of insights.
Hey everyone! Today, I'm unlocking the power of Tableau by diving into one of its most transformative features, calculated fields. Whether you're new to Tableau or looking to refine your skills, mastering calculated fields can take your data analysis to the next level. So, what exactly are calculated fields? They're custom fields you create using a formula to generate new data from your existing dataset. This means you can create dynamic metrics tailored to your specific needs. Let's break it down. First up, basic formulas. This is where it all begins. In Tableau, you can use basic calculations to perform simple arithmetic operations like sums, averages, and more. For instance, if you have sales data and you want to find the average sales per month, you can create a calculated field with the formula AVG, sales. It's as simple as that. Next, let's talk about profit margin calculation. Knowing your profit margin is crucial for understanding your business's profitability. To calculate it in Tableau, you can subtract your total costs from your total revenue and then divide by total revenue. The formula looks like this: revenue, cost, revenue. Once you've created this field, you can drag it into your visualization to instantly see your profit margins. But wait, there's more. Growth rate calculation is another powerful tool you can use to analyze percentage changes over time. Let's say you want to see how your sales have grown from month to month. You can create a calculated field using the following formula: sum, sales. Lookup, sum, sales, -1. Lookup, sum, sales, -1. This will show you the growth rate for each period, helping you identify trends and make informed decisions. Using these techniques enhances your data insights significantly. By creating custom metrics, you can build more detailed and actionable visualizations. This is the essence of what makes Tableau so powerful: its ability to transform raw data into meaningful insights. And there you have it. By understanding and utilizing calculated fields, you're well on your way to becoming a Tableau pro. Remember, the key to mastering Tableau is practice and experimentation. So dive in and start creating those dynamic metrics. Thanks for watching. If you found
Calculated fields allow users to create new data from existing data within a visualization tool. Basic formulas can include arithmetic operations such as addition, subtraction, multiplication, or division. Understanding how to use these formulas is critical for deeper data analysis. To calculate profit margin, we use the formula revenue cost/revenue. This calculation helps in assessing the profitability of products and services. Creating a calculated field for profit margin can provide valuable insights into financial performance. The growth rate can be calculated as current period value, previous period value, /previous period value, *100. This metric illustrates the pace at which a company's revenue or profit is growing over time, allowing for better strategic planning.
Hey there, ready to unlock the full potential of Tableau? In this video, I'm going to walk you through some essential functions that you need to know. We'll dive into date functions, string functions, and how to use these functions for deeper analysis. Let's get started. First up, date functions. Tableau lets you manipulate date data in so many ways. For example, the date_ADD function allows you to add a specific number of days, months, or years to a date. Handy for projecting future data trends, right? Then there's the date diff function that calculates the difference between two dates. Imagine you want to find out how many days your sales cycle takes. Data diff makes it super easy. And don't forget about the date trunk function, which can truncate dates to the nearest quarter, month, or even week. It's perfect for summarizing data into more digestible time periods. Next, let's talk about string functions. These are essential for cleaning and transforming text data. The left function, for instance, returns the first n characters from a string. This is great when you need to extract specific parts of text, like pulling out the area code from phone numbers. The split function is another gem. It separates a string into multiple parts based on a delimiter. Need to break down full names into first and last names? Split has got your back. And let's not overlook the trim function, which removes any leading or trailing spaces. Say goodbye to those annoying extra spaces messing up your data. Now let's take these functions and apply them for deeper analysis. Using functions can help you uncover insights that are not immediately visible. For example, combining datepart with an aggregation function like sum can help you analyze sales performance by specific days of the week. Or use a combination of if statements and string functions to categorize and group your data more effectively. These techniques allow you to refine your data, so you can focus on what really matters. Remember, the key to mastering Tableau is practicing these functions and experimenting with different combinations. The more comfortable you get, the more powerful your data analysis will become. So take the time to play around with these functions and see how they can transform your data insights. Thanks for watching.
Date functions enable users to manipulate and analyze dates and data sets. Common operations include finding differences between dates, extracting specific components, like year or month, or formatting dates for better readability, all essential for time series analyses. String functions facilitate the manipulation of text data. These include concatenation, substring extraction, and text formatting. Utilizing string functions can improve data representation and analysis, especially when working with categorical data or labels. Functions enhance data analysis by automating calculations and transforming data. By utilizing functions like aggregations, calculations, and conditional statements, data analysts can derive actionable insights quickly and efficiently. These functions help in dissecting trends, patterns, and outliers in the data.
Hey everyone! Today I'm super excited to dive into advanced charting techniques that'll help you unlock powerful business insights. As data scientists, we know how crucial it is to visualize data effectively, so let's get into it. First up, we have dual-axis charts. These are game changers when you need to compare two different data sets on the same graph. Imagine you want to compare sales and marketing spend side by side. With dual-axis charts, you can plot sales on one axis and marketing spend on the other. It's like having two charts in one, giving you a dual perspective that's way easier to digest at a glance. Next, let's talk about combined charts. Sometimes a single chart type just doesn't cut it. That's where combined charts come in. They allow you to mix different chart types, like bar charts with line charts on the same graph. This combination can highlight relationships between two data sets more clearly. For instance, you could use bars to show monthly revenue and a line to show the cumulative annual revenue. This layered approach brings out insights that might be missed with a single chart type. Now, let's zero in on visualizing sales and profit. Financial data can be dense and intimidating, but with the right charts, it can tell a compelling story. Stack bar charts are fantastic for this. You can stack sales and profit margins in different colors, making it easy to see not just the totals, but the contribution of each segment. Heat maps are another great option. They can show performance across different regions or product lines, making it easy to spot trends and outliers. Advanced visualization methods like these aren't just about making pretty graphs. They're about making data more accessible and actionable. When you present data clearly, it's easier for stakeholders to grasp the key metrics and make informed decisions. So there you have it. Dual-axis charts for comparing datasets, combined charts for enhanced insights, and effective techniques for visualizing sales and profits. Remember, the goal is to make your data tell a story. The more effectively you can communicate that story, the more valuable your insights will be. Thanks for watching. Don't forget to like and subscribe for more tips on mastering data visualization. Until next time, happy.
Dual-axis charts allow the visualization of two distinct data sets on a single graph, each with its own axis. This is useful when comparing different metrics, like sales and profit, over identical time periods. The dual-axis approach enables clearer insights when data scales greatly differ, promoting easier interpretation. Combined charts integrate different chart types, e.g., bar and line, to visually represent relationships between datasets. This method provides a comprehensive view, allowing for revealing correlations and trends that might not be visible through separate charts. It's particularly effective in juxtaposing related data for comparative analysis. To visualize sales and profit together, one can employ dual-axis or combined charts. This allows stakeholders to quickly assess profitability trends relative to sales volumes. Effective visuals enhance communication about financial health, guiding strategic decisions based on profitable product lines or seasonal performance.
Hey everyone, Marquez here. Today I'm diving into a game changer for all you data enthusiasts out there. We're talking about parameters in data analysis. Stick around because by the end of this video, you'll be unlocking the full potential of your data sets. Alright, let's kick things off with the basics. What are parameters? Simply put, parameters are user-controlled inputs that allow you to create flexible and dynamic analyses. Think of them as variables that you can tweak to see how different values affect your data. It's kind of like adjusting the settings on your favorite game to see how it changes your experience. Now, let's get into how you can actually create these parameters. Most data analysis tools like Tableau or Excel have built-in functions to help you set these up. You start by defining the parameter. Give it a name, a data type, and set possible values. Once that's done, you can link your parameter to different parts of your analysis, like filters, calculations, or even visualizations. Super simple, right? But why should you care about parameters? Here's the cool part. They make your data analysis way more interactive and adaptable. Imagine you're analyzing sales data. With parameters, you can easily switch between different time periods or regions without having to create separate dashboards. Or say you want to test different scenarios like price changes or marketing budgets. Parameters let you do that on the fly. It's like having a Swiss Army knife for your data. Let's look at some practical use cases. First up, filtering. With parameters, you can create dynamic filters that let users select what they want to see. This is perfect for dashboards that need to cater to different audiences. Next, calculations. Parameters can be used to perform what-if analyses, adjusting key variables to see potential outcomes. This is incredibly useful for forecasting and planning. Finally, parameters can enhance your visualizations by allowing users to interact with the data in real time. This makes your presentations not just informative, but also engaging and interactive. So, what are the benefits of using parameters in your data analysis? For starters, they offer a level of interactivity that static reports just can't match. They empower users to explore data in a way that's meaningful to them, leading to deeper insights. Plus, they make your analyses more adaptable, allowing you to quickly respond to changing needs or new information. In conclusion, if you're looking to take your data analysis to the next level, parameters are the way to go. They offer flexibility, interactivity, and adaptability, making your data exploration experience richer and more useful.
Parameters are dynamic values that can replace fixed values in calculations and filters, allowing users to adjust visualizations with ease. They enhance interactivity in reports and dashboards, letting end users adapt their views according to specific criteria or scenarios, ultimately enriching the analytical experience. Parameters can be used for a variety of applications, including adjusting thresholds and calculations, switching measures for visualization, or filtering data dynamically. They empower users to customize their analytical perspectives without needing to modify underlying data structures. Using parameters enhances the flexibility and dynamism of data visualizations. They promote user engagement, as stakeholders can manipulate variables for tailored insights. This adaptability can lead to more informed decision-making as users explore different scenarios and their implications.
Hey Tableau enthusiasts, today I'm unlocking the power of level of detail expressions, or LODs, in Tableau. Let's dive into fixed, include, and exclude expressions and see how they can supercharge your data analysis. First up, fixed LOD expressions. They do exactly what their name suggests. They fix your data at a specific level of detail. For instance, if you want to calculate the average sales per region regardless of any other filters, you'd use a fixed expression like this. Fixed, region, AVG, sales. Simple, right? Now let's talk about include LOD expressions. These guys are all about flexibility. They allow you to add dimensions to your aggregation without changing the overall level of detail of your visualization. Imagine you're analyzing customer data and want to see the average order value per segment, including different product categories. An include expression like include product category, AVG order value, does the trick. Last but not least, exclude LOD expressions. These are your go-to when you want to remove certain dimensions from your calculations. For example, if you want to calculate total sales by region but exclude the effect of individual cities, you'd use an exclude expression, exclude city, sum, sales. It's like magic, data magic. So when should you use LODs over table calculations? Table calculations are great for quick, in-the-moment insights, but they're limited to the scope of your current view. LODs, on the other hand, give you the power to break free from those constraints and define your data exactly as you need it. Let's put this into practice with some examples. For cohort analysis, fixed LOD expressions can help track customer retention over time by fixing the cohort group and analyzing retention rates. Customer segmentation, include LODs are perfect for adding layers to your segmentation, like seeing average spend per segment while including product categories. Remember, mastering LOD expressions in Tableau is a game changer. They offer an unparalleled level of control over your data, helping you derive more precise and insightful analytics. So go ahead, experiment with fixed, include, and exclude LODs and take your Tableau skills to the next level. Happy analyzing.
Level of detail, LOD, expressions such as fixed, include, and exclude provide advanced calculations that go beyond the standard aggregation methods in Tableau. The fixed expression calculates values independently of the visualization level of detail, maintaining consistent output regardless of the dimensions included in the view. Include allows additional dimensions to be included in the calculation while considering the context of the view. Exclude, conversely, removes certain dimensions from the calculation. Each serves specific analytical purposes, enabling more nuanced insights into data. LOD expressions and table calculations can both perform complex analyses, yet they operate on different principles. While table calculations depend on the specific data arrangement in the view, LOD expressions calculate values based on a defined level of detail, regardless of visual arrangement. This key difference allows LOD to provide reliable calculations across various contexts, making them ideal for analyzing data slices that table calculations may overlook. Cohort analysis involves analyzing subsets of data to track performance over time. Through LOD expressions, analysts can assess behaviors, such as customer retention and lifetime value, by comparing different groups, cohorts, over specific periods. For example, using fixed LOD can help isolate customers acquired in the same quarter to evaluate their purchasing habits distinctly. Such analysis is essential for understanding long-term trends and making informed business decisions. Incorporating advanced visualizations and calculated fields proficiently enhances data analysis. Understanding how to utilize calculated fields, functions, parameters, and LOD empowers users to create insightful presentations. By mastering these techniques, professionals could drive more strategic decisions based on data.
Assignments. Use any sources, for example, Superstore datasets, Kaggle, or data.gov. Apply calculator field, for example, basic arithmetic or logical calculation, or date or string manipulations. And then visualization, at least 3. You can choose bar, line, map, head map, scatter plot, or tree maps. Save your assignment report in Word or PowerPoint as assignment 10. Store it in Dropbox and pass URL from Dropbox into this material. Good luck. Berikut merupakan referensi yang terpakai pada mata kuliah manajemen sistem